Yes, once again, you are most welcome to this another interesting part of mathematics, specifically which we can refer to as what? As Surds. So like there we looked at other topics, we can also look at this one here in the same way. And by the end of the day or the session, we are going to be able to work out some numbers in this part of mathematics. So the topic is known as surds, and here let us begin by saying a surd is an irrational number. Okay, a surd is an irrational number. It can also be defined as a root of a number which cannot be expressed as a fraction. So here we are saying a surd is an irrational number. Like for example, we have listed down here examples of surds. Like for example, root of 3, root of 5, we have root of 7, even root of 11, okay, root of 10. All those ones are what? Surds. Why? Because they are irrational. There's no way we can simplify them further and the root disappears. So any number which is of this form, whereby we cannot, when we simplify it, the root does not disappear, that number is known as a surd or an irrational number. So the examples of the examples of surds, we have some of them here. Yes, but when you have root of 4 is not a surd. Why? Because you can simplify it further and the root disappears. Like root of 9, it is not a surd. Root of 16 is not. Okay, root of 25, those ones are not surds. Like cube root of 8, it is also not a surd. Why? Because the root can disappear. So here we are going to be looking at these ones here. Those numbers whereby the root cannot disappear even though we simplify, like the way you can be able to see here in some of the examples which we have worked out, the root remains there. When you look at also here, the root remains there. Even though you simplify, the root remains there. So these ones are surds. Okay, so let us look at them. Now, if we are to understand them very well, the first thing which we are supposed to look at is rules of surds. Okay, so these rules here, we are going to apply them while operating on surds. So among the rules, we have the first one, like root of a times root of b. So when you have here this, we are multiplying root of a and root of b. Both a and b are under square roots. Okay, so if we are to simplify this one here, we can set the same as, we can write a single root. We can write a single root, and then inside we get a times b, like the way you can be able to see here, whereby it gives us an answer as root of ab. So this is a rule, it is a fundamental rule, it is very important. So long as a and b are under a square root. Okay, so we can multiply them, like root of a times root of b is the same as root of a times what? B. So this is one of the rules. And then we can also look at the second one. After understanding the first one, we can also look at the second one. And the second one is root of a times root of a. So still using the above knowledge, we simply write a single root, and then inside the root it will be a times a, of which it gives us a squared. So meaning we are going to be having root of a squared, and root of a squared, the root cancels with the square on a, and therefore the answer which we get here, it is what? It is a. This is another rule in surds. The third one, we can also look at this one here, a root b plus c root b. Okay, so when you look at these ones here, you find we need some little knowledge of factorization. okay, because in the first part there's root of b, and then the second part there's also root of what? B, meaning there's a common factor. So when there's a common factor, we can come here and we factorize out the common factor, which is root of b. So when we factorize out the common factor, which is root of b, inside the bracket we remain there with z, a, and then c. But remember, it was addition, so that's why here we are having a plus c outside the bracket root of b, because it was common. We factorized it what? Outside. Okay, now this one here, this rule, we can illustrate it with any example here. Like here, for example, 3 root of 5 plus 2 root of 5. How can we simplify this? Okay, so we are going to use this rule to simplify this one here. Okay, so 3 root of 5 plus 2 root of 5 is the same as, still when you check on it, root of 5 is common. It is a common factor here. Okay, because this is addition, root of 5 is a common factor. So if you are to simplify it, pull out the common factor, and when you pull out the common factor, which is root of 5, inside the bracket you remain there with 3 plus 2. So therefore, leading us 3 plus 2, we get 5, and then times root of 5. So the answer which you get is 5 root of what? 5. So that's how we can apply the third rule in simplifying what? Surds. Let us come to the fourth one, the fourth rule. We are having a single root of a divided by b, root of a divided by b. So this root is affecting both the numerator, which is a, and the denominator, which is what? B. So if we are to just simplify it, we can separate them, whereby we write a, it is affected by root, so root of a divided by also root of b, because this root is for both of them. That is in division. Okay, for example, we can also see here, it is any application, it is using this rule. We are using this rule to simplify this. So here we are having root of 5 divided by 4. So we have to separate them, whereby the numerator, it will be root of 5, and then the denominator will be root of what? 4. So remember, root of 5, it is a surd, or it is irrational, so we just leave it like that. But the denominator, which is root of 4, it's not a surd, it is not irrational. So for it, we can simplify it, and the root disappears, and the answer is what? 2. So meaning the answer which we get there, it is root of 5 divided by what? 2. Okay, so that is it about some of the rules of surds. We have to take note of them seriously. Now let us go to some examples here which we can use these rules. Like here we are saying expressing surds in the form a root b. So they are saying here express the following surds in the form a root what? B. So let us look at them together. We have a, which is root of 18, b is root of 72, c is root of 75, and then d is root of 300. So let us just look at them together. We got solutions. The first one is a. Let's begin with a. And when you check at a, it is root of 18. So if it's root of 18, when we are to simplify or to express this in the form of a root b, the first thing which we look at, in this 18, is there a square number which is a factor of 18? The answer is yes. And the square number which is a factor of 18, it is simply 9. So meaning root of 18, we can write it as root of 2 times 9, whereby 2, it is not a square number, but 9, it is a square number. But when you multiply them, you go back to 18. So meaning After that, the root affects both, it affects 2 and it affects 9. So therefore here it will be root of 2 times root of 9. And remember, root of 2 is irrational, or it is a surd, so you cannot simplify it further. But root of 9, it is not irrational, so you can get the root of 9, which is 3. And when you get root 2 times 3, you get 3 root what? 3 root 2. That is how we can get for a, which is root of 18. So we have simplified it, or we have written it in the form a root of b. Let us move away from that. We come to b. B, we have root of 72. So still we ask ourselves, in 72, which factors of 72 and it is a square number? The answer is 36. Okay, so if it is 36 when we multiply it with 2, we go to 72. So it is going to help us. So whereby we write root of 2 times 36. We do like there we have done in a, which is root 2 times root of 36, and root 2 is a surd. Root of 36, we get the answer as 6. So when you multiply root 2 times 6, we get 6 root of what? 2. So we have simplified it. Come to see, you do the same. Okay, root of 75. So within 75, there's 25, which is a square number. Okay, so here we have to say 3 times 25 under a same root. So you separate them. That's root of 3 times root of 25, which is root of 3 times root of 25 is 5, and the answer here is 5 root of what? Of 3. Then lastly we have root of 300, which is the same as root of 3 times 100. 100 is a square number, so that's why we are using it. So it will be root of 3 times root of 100, which will be root of 3 times 10, because 10 is, we are getting it from root of 100, and therefore the answer which we get there, it will be 10 root of what? Of 3. That's how we can express these numbers here in the form a root of what? B. So that is it about that. Maybe I can leave you with some numbers here, which you can be able also to what? To practice. So this will be your exercise that express the following surds in the form a root of what? Of B. You have a, which is root of 50, B, which is root of 128, C, root of 243, and then D, which is root of what? 500. So use the earlier knowledge which we have gone through to work them what? Out.